The universe, the last frontier. Billions of galaxies containing billions of stars. Like our own Milky Way galaxy. As a tiny speck in one spiral arm of our galaxy, we find our solar system of planets, including planet Earth. Earth is the only known water planet in our universe supporting life as we know it. Nevertheless, it is expected that virtually all of the billions of stars in galaxies nurture their own solar systems of planets. Some of these planets may be terrestrial, but lack the liquid or frozen water necessary for life as we know it. Yet, there are likely to be many Earth-like planets in the habitable zones of their suns that harbor water. How did water arrive on Earth and on other habitable planets? How is water in all its forms throughout the universe connected with dark matter, dark energy, astrobiology, and the origin of life? The way of quintessential water in cosmology and astrobiology. A film by Professor Keith Johnson, MIT. This film is based on the recent publication by Dr. Johnson in the International Journal of Astrobiology. Stars are born in water-rich nebulae, such as the Orion Nebula, and they die as supernovae exploding cosmic dust. Cosmic dust from supernovae explosions, a scourge to many astronomers, some who may even have lost a Nobel Prize because of it. Yet, cosmic dust, coated with thin layers of amorphous water ice, is a blessing in disguise. With the help of incident cosmic radiation, water nanoclusters are ejected into space from the amorphous water ice coatings of the cosmic dust. We know that water molecules form hydrogen bonds with each other to form liquid water and ice. It is also known that water molecules can bond to form nano-sized clusters. Here we see 5 water molecules forming a pentagonal nanocluster. This nanocluster vibrates in the terahertz region of the electromagnetic spectrum. Its cutoff vibrational frequency is 1.5 terahertz. The lowest entropy nanocluster formed by water pentamers is a pentagonal dodecahedral cluster. The dodecahedron contains a hydronium ion, H3O+. This water nanocluster also vibrates at terahertz frequencies. These water nanoclusters are dodecahedrally shaped and have quantum Rydberg electron states, shown here to extend beyond each cluster. They are the basis for Rydberg dark matter. Over 30 years of searching for dark matter, proposed exotic elementary particles such as WIMPs and axions have not been observed experimentally, even in the latest large underground xenon lux and MIT abracadabra detectors. Nor have the WIMPs predicted from supersymmetry theory been created in the CERN Large Hadron Collider. Other types of dark matter, such as neutrinos and black holes, have been suggested, but thus far not enough of it has been found. In conclusion, stable dodecahedral water nanoclusters, ejected from amorphous ice-coated cosmic dust, constitute Rydberg matter. Rydberg matter interacts, or becomes quantum entangled, over long distances in space, causing it to be transparent to visible, infrared, and radio frequencies. Thus, it is one form of baryonic dark matter. Rydberg matter is a low-density substance, so that one doesn't need a lot of it to explain dark matter, compared with non-baryonic elementary particles, such as WIMPs, axions, and neutrinos. Observations of CMB galactic dust foreground polarization show that the power of the E mode is twice that of the B mode, whereas they should be equal. This may be due to twice the power of the 3 water cluster Hg squashing vibrational modes compared to that of the 2 Hu twisting modes, power being proportional to the squares of their amplitudes. They vibrate and twist at terahertz frequencies, contributing radiation to the CMB between 1 and 6 terahertz. The indicated anisotropic dipole moments along the nanocluster axis are precursors to water nanocluster birefringence, analogous to the terahertz-induced birefringence of liquid water. This is because a liquid water film is composed of a network of water nanoclusters, which are birefringent under terahertz-induced stimulation. Observational evidence for birefringence of the cosmic microwave background has recently been reported. The suggestion that the cosmic microwave background polarization may be due to cosmic dust emission polarization is actually support for our claim that cosmic birefringence is real and indicative of quintessence new physics. This is due to the anisotropic dipole moments of water nanoclusters ejected from cosmic dust as they capture vacuum energy by the dynamical Casimir effect and vibrate at terahertz frequencies. As support for this theory, the Hubble Space Telescope has revealed a galaxy, NGC 1052, 72 million light-years from Earth, where one can literally see through to other galaxies behind it. It is an ultra-diffuse galaxy, almost as wide as the Milky Way, but contains only 1/200th of the number of stars in the Milky Way. The galaxy contains, at most, only 1/400th of the amount of dark matter expected from theory. The galaxy ultra-diffuseness suggests a lack of the cosmic dust characteristic of most galaxies, thus connecting dark matter to cosmic dust. The first known interstellar object, Oumuamua, entered our solar system in 2017 and has been a mystery ever since. Theories of its origin abound, including alien. The most likely origin is natural, as described in the recent publication. In the following, we elaborate on this fractal dust scenario and suggest that Oumuamua may actually be a source of cosmic dark matter. While Oumuamua is very large compared to nano-sized cosmic dust, around 100 meters long and possibly disc-shaped, it should be covered by layers of amorphous water ice. The fractal nature of this huge dust aggregate, combined with the effects of solar and cosmic radiation, should promote the ejection of water nanoclusters to interstellar space. There, water clusters constitute a form of Rydberg baryonic dark matter, as is the case for ordinary cosmic dust, and thus will be invisible. This explains the lack of a cometary tail, which had ruled out the theory that Oumuamua is a comet. The ejection of water nanoclusters from Oumuamua may also promote its rotation. Where in our galaxy did Oumuamua come from? Was the otherwise natural fractal dust object with its amorphous water ice coating possibly engineered purposely? Could the ejected water nanoclusters comprising Rydberg matter have another cosmic goal and cosmology implications? What about dark energy, which is believed to be responsible for the accelerating expansion of the universe? Unfortunately, quantum field theory predicts a dark energy density associated with quantum fluctuations of the vacuum that is too large by 120 orders of magnitude. This is called the vacuum catastrophe. To solve this problem, we first view the vacuum electromagnetic field as a collection of quantized harmonic oscillators of normal mode frequencies, nu sub k, summing over the 0-point energies of each oscillator mode. h is Planck's constant, and c is the velocity of light in a vacuum. This leads to the energy density equation shown here. The wave vector, k, signifies the normal modes of the electromagnetic field that are consistent with the boundary conditions on the quantization volume, V. As V approaches infinity, one obtains the right-hand side of the equation. We can remove the infinity by replacing the upper limit of the integral by a cutoff frequency set by the Planck scale, but this still results in a huge vacuum energy by 120 orders of magnitude. If instead, we subtract the energy density, ρ sub c, of virtual photons of zero-point vacuum fluctuations captured by ejected water nanoclusters through the microscopic dynamical Casimir effect, the divergent integral is largely cancelled. Nu sub c is the cutoff vibrational frequency of the ejected water nanoclusters. This leaves the finite quantity shown to be identified with the dark energy density. For the prominent pentagonal dodecahedral water nanocluster, the cutoff vibrational frequency is approximately 1.7 terahertz. This formula produces the correct, small dark energy density and consequently, the small cosmological constant. To summarize visually, cosmic water nanoclusters can absorb vibrationally, by the microscopic dynamical Casimir effect, the unwanted high-frequency virtual photons of zero-point energy vacuum fluctuations. Only vacuum fluctuations below the water nanocluster cutoff vibrational frequency are gravitationally active. The water nanocluster E and B vibrations, induced by the capture of vacuum energy, is an unlimited source of energy. It would be implemented in reactors harvesting the water nanoclusters ejected to space from cosmic dust and using their hydrokinetic energies as propellant. These reactors would be the power sources for a starship and its drones. Because of the prodigious amounts of cosmic dust in our Milky Way galaxy, there would also be a wealth of ejected water nanoclusters holding enough captured vacuum energy to fuel an interstellar mothership and its drones throughout our galaxy, perhaps even to the farthest quasars and their black holes. How are cosmic water nanoclusters and their role in dark energy, described by the preceding equation, possibly related to the origin of life on planet Earth and other planets or moons? One popular theory is that ribonucleic acid, or RNA, a precursor to DNA, is the origin of all life. Like DNA, RNA is a polymer consisting of nucleotide sequences, which are composed of nitrogen-containing bases, sugar molecules, and phosphate groups. Cosmic water nanoclusters provide a catalytic pathway for the exchange of water molecules between these prebiotic substances. This leads to the polymerization of RNA, as shown here by the sequence of 4 nucleotide bases, guanine, adenine, uracil, and cytosine. This may explain how the first self-replicating RNA polymers were created in pools of prebiotic molecules, and thereby clarify the so-called RNA World origin of life, preceding DNA and protein-based life on planet Earth and exoplanets in the habitable zones of developed solar systems, wherever water is present. One of the largest and most distant reservoirs of water detected in the universe exists in a high-redshift quasar more than 12 billion light-years away. A quasar is an extremely bright active galactic object in which a supermassive black hole, with mass ranging from millions to tens of billions of times the mass of our Sun, is surrounded by a gaseous accretion disk. The quasar water vapor mass is at least 140 trillion times the mass of all the water in the oceans of planet Earth, and 100,000 times more massive than our Sun. The quasar water vapor produces cosmic water nanoclusters. They are a coolant for rapid early star formation. Gravitational collapse of these stars leads to a massive spinning black hole like that shown here. The entangled, low-entropy water nanoclusters that helped create the stars that collapse to the black hole will be pulled into it by its gravitation. Inside, they constitute exotic matter with negative pressure that promotes wormhole formation. Is it possible that the raining down by these water nanoclusters on a planet that was associated with one of the collapsing stars, but is now captured by the black hole, could provide the water necessary for life on that planet? Perhaps even a water planet, such as those in the science fiction film Interstellar, where a team of scientists, attempting to save humanity from a dying Earth, travel through a wormhole and land on water and ice-covered planets near a black hole. At far enough distances from the black hole, at least 10 light-years, the gravitational environment is stable enough for planets to form from the dense dust of the accretion disk. According to published research, more than 10,000 planets are possible around a supermassive black hole. For such a planet, the accretion disk would be as bright in the sky as Earth's sun. Because such quasars and their associated massive black holes are the oldest objects in the universe, even a few life-supporting planets there would allow for the possibility of technologically advanced civilizations to exist not long after the very beginning of the universe. Such a civilization may have launched probes into the black hole to investigate its space-time singularity, and possibly engineered a stable wormhole pass-through to the other side. The human brain is approximately 75% water by weight. Much of that water is in the form of nanoclusters inside the neuron microtubules. Their terahertz vibrations are a basis for human consciousness. If this were true also for an early advanced civilization, information carried by the quantum-entangled water nanoclusters, and thus consciousness itself, could be preserved as one is swept through the wormhole connecting the black hole to a white hole in another part of the universe. The quantum-entangled, low-entropy water nanoclusters, and the conscious information carried by them, could possibly survive and be transported out of the wormhole, as so-called Hawking radiation, into another part of the universe. What universe? A popular cosmology theory is the multiverse, which follows from the inflationary Big Bang theory. In the multiverse, it is likely that few universes have the exact physical constants that permit the existence of water and other prebiotic molecules necessary for planetary life as we know it. In contrast to the multiverse, the parallel universes, or many worlds theory, derived from quantum mechanics, predicts an infinite number of nearly identical worlds. Here parallel lives occur simultaneously, but we have no practical way of entering or communicating with those worlds. In the present theory, we have proposed that supernovae produce ice-coated cosmic dust that ejects water nanoclusters, filling space as a quintessent scalar field of dark matter. Like the fifth element of Plato and Aristotle. This is the terahertz radiative mode of an ejected pentagonal dodecahedral water nanocluster, equal in frequency to the 1.7 terahertz value in the formula, that agrees with the presently observed dark energy density. The indicated anisotropic dipole moments along the nanocluster axis are precursors to water nanocluster birefringence, analogous to the terahertz-induced birefringence of liquid water. Observational evidence for birefringence of the cosmic microwave background has recently been reported. As our universe continues to expand, water nanoclusters ejected from cosmic dust will grow larger, and their vibrational frequencies will decrease. Large water clusters are less interacting with the prebiotic molecules of life. With decreasing vibration frequency, dark energy density also decreases. The universe will stop expanding and contract as the gravity of the remaining matter takes over. The universe will expand again, leading to a single cyclic universe, instead of an inflationary multiverse. According to this scenario, we are presently living at the ideal time in our universe for life, as we know it, to exist. And water nanoclusters, ejected from cosmic dust, could be the seeds of life throughout the universe.